Okay, this is 5.9. It's not really 5.9 because there's no actual section 5.9 in your book. But it's a topic I want to cover that's not in your book, so I'm just making up a new section. It's called the intercept form or the root form of a quadratic. It's basically given you a quadratic in factored form, or it's already been factored, which means that you have roots or intercepts at x equals p and at x equals q. Just like everything else with these formulas, we have to be very wary of these negative values. Negative p means that p is my actual intercept, and negative q means that q is the actual intercept. So like here, there's a root or intercept at p and a root or intercept at q. One of the nice things about this form, besides the fact that it gives you the roots right away, is you know, since parabolas are symmetric, the vertex is going to be halfway in between them, wherever that is. Halfway between them is where your AOS falls. Somewhere on that AOS is the vertex. So you can calculate the AOS, and there's the formula you can use to find halfway between if you want to. Take whatever that number is and plug it into your equation. And I'll show an example of that, but I would take this number and plug it in both here and here, and calculate that to find the vertex. The y-intercept is actually always just going to be this number times this number times this number with the negatives. A times p times q will always be your y-intercept. Let's just do a quick example. Shouldn't take too long. Right now, my a value is -1. My p value is 3. My q value is -2. So I have a root at 3 and a root at -2. Those are my two roots. So obviously if I plug a 3 in for x, that would become 3 minus 3 times 3 plus 2, which is -0 times 5, which is still just 0. So 3 is a root for the same reason, so is -2. I want to go halfway between those. And this is a total distance of 5, so halfway between those is 2.5, which would be right there at 1/2. So my AOS is really this line right here at y equals 1/2, which I didn't really draw very well there, so maybe I'll try all that again. Well, I lost everything there. I apologize about that. Let me just get rid of this. I have something here. Yeah. I have something here. I have something here. And I'm going to go halfway in between them. Let's see if this comes out any better. 2.5 would be basically here. There's the AOS cutting my graph in half. But now, because my A value is -1, I know this graph is going to point down. It's going to frown. But I have to actually take 0.5 and plug it in for x to find the vertex. I do f of 0.5. Something really interesting happens here. These two bubbles will always work out to be the same. In this case, I get -2.5 times +2.5. So I say the same, I guess I mean they're opposites of each other. So I'm really doing 2.5 times 2.5. -2.5 times -2.5 is 6.25. So if I go to 6.25 way up here, that's where my vertex is. Now to find the y-intercept is always just a times p times q. It's actually very nice in that sense. So it's 1 times -1 times 3 times -2 is +6. So I have the y-intercept here, so I have this point as well. I might as well plug in a 2 at this point to see what that coordinate's going to be. If I plug a 2 in for x, this becomes -1 up here, this becomes +4 up here, so it's actually just 4. I have a 0.24, and I have a point -1,4. I even could use my AO or my A value, which is -1, and from my vertex go down 1, right 1, which would be here, and down 1, left 1. So I can get a bunch of really good points in a hurry. Now if I can just graph a parabola well, I'd be set, but I can't do that anymore. I lost my touch. And there's my parabola. Pretty straightforward. Now, if you don't like this form, one of the best things about it is you can always just FOIL to get into standard form if you would rather. When you do the foiling, you really want to do the parentheses first and leave that negative out there. If there was like an a value, like -4 or something, do that last. It's much easier that way. When I FOIL this, I get x squared plus 2x minus 3x minus 6, and that's all still negative, so it's negative x squared minus x minus 6. I distribute the negative, it's negative x squared plus x plus 6. So this is now in standard form. If you'd rather find it that way, you can still do your negative b over 2a and all that good stuff. One thing to notice, this right now is not in intercept form because of this. If I wanted to put this in true intercept form, I would have to factor a 3 out of this bubble. When I factor a 3 out, I get x minus 4/3. I divided this by 3 and divided this by 3. Then these combined. Now I'd be in intercept form and I can go from there. Thank you very much.